Here we go. It says, will a precipitate form? And I'm adding two solutions. Calcium iodide, you know this is soluble because I gave you molarity. And PT nitrate, PT platinum nitrate, again I gave you molarity. And I gave you KSP, it can't be for this, it can't be for this. If I make the reaction, it's a double displacement, so you're going to make what? PTI4 plus. Now you don't have to really balance this because that's not what the problem about, but this is soluble because I gave you the molarity. This is soluble because I gave you the molarity. This is soluble because it has the nitrate. This must be the precipitate. Okay, so that's the one the KSP is given for. So now what we're going to say is I minus, and we have, actually I don't want K, I'll use pi for product, because Q means you're doing what? Reaction quotient, right? Here we're doing solubility product, so we don't have a quotient. You could call it the solubility product quotient. But basically, we're looking at the concentration of platinum and comparing it to K. And we know that if the Q, or this pi as I called it, I'll put Q here to relate it to what we did before. If this Q is bigger than K, means these numbers are too big, it's going to go this way and make precipitate. If Q is less than K, wants to go that way to get to equilibrium, whatever precipitate you have will dissolve. Okay. So now we want to see whether we make a precipitate by mixing these two things, and it's going to time me out. Okay, get rid of that. Okay, so this is the dilution problem for the kinetics experiment. In other words, I'm taking this amount of iodide, it's the concentration from calcium iodide, the concentration of I minus is originally 2 times 0.065 because there's 2 iodides. And it was 20 milliliters. The final solution, somewhere did say assume additive, no I didn't say that. But you have to assume the solution is additive, just like we did when we calculated the H2SO4, the potassium permanganate and everything. So the total volume is 35 milliliters. So we have 35 times X is equal to 20 milliliters times 0.130. This will give us the concentration of the iodide after we mix the two solutions, which we'll plug into this one. Then we want to get the concentration of the platinum. There's only one platinum there, so essentially we're going to have 15 milliliters times equals, and the total volume is still 35 milliliters. Plus concentration. So essentially, that's the dilution problem. Platinum is 0.137 molar. Solving this. The iodide is 0.0742. Four. 0.137 is what I said. I can't read my writing. And I get 4.17, 10 to the minus 6. The KSP here was 10 to the minus 8, so that's bigger. So that means the reaction goes this way and we make a precipitate. Okay? So we're going to, the answer to this question, in other words, I simplified it from the old days, we make a precipitate. The next question that I used to ask, which I'm not going to ask, is what are the concentrations of each ion at equilibrium? So we're going to make a precipitate, then there's going to be excess. One of these is going to be the excess. That will be the common ion. Okay? And then you do the KSP to calculate the other concentration. Notice that was a much harder problem. I haven't asked that in several years. But I used to ask that. Because it was part, that was my common ion problem in the old days. So basically, we know there is a precipitate, so the next thing we can do, I have enough time? I don't have enough time. I'm done doing that. We're not going to do it.